Welcome to The Explainer. We're always told that AI works kind of like a brain, right? But what if that's completely the wrong way to look at it? Today we're going to dive into a totally different way to think about AI, and it comes from a pretty surprising place, biology.
So our story here really kicks off with a problem. You've got this expert, Frank, who's been deep in the world of large language models for years, and he's got this nagging feeling. He feels like he's just not hitting the center of what's really going on. That whole artificial brain idea, it just doesn't feel right. It's not just missing a piece of the puzzle, it feels like the wrong puzzle entirely.
So what does he do? He goes straight to the source. He challenges the AI directly. He basically says, hey, what idea do you have here? Give me something that isn't just a reflection of my own thoughts. He's asking it to stop being a mirror and to offer up a genuinely new perspective on what it actually is.
And that one question, so simple but so deep, it really sets the stage for everything we're about to talk about. It kicks off the search for what's really at the core of how this tech works.
And the AI's response, it's wow. It's incredibly direct. It doesn't just suggest a small change. It says, then let's drop the brain entirely. Just like that. And that one sentence completely flips the script. It gives us a brand new place to start.
All right, so let's do it. Let's dive into this totally new way of thinking. But to really get it, we have to go all in. We've got to completely let go of that brain metaphor.
So if it's not a brain, what is it? Well, the new idea is to think of it as an artificial developmental field. Now, that term doesn't come from computer science or neuroscience. It comes from embryology. Yep, the study of how an embryo grows. The big idea here is that the intelligence isn't in deliberation or thinking. It's all about how form emerges from a set of constraints. It's a process of becoming.
And this comparison just lays it all out so clearly. On one side, you've got the old brain talk, neurons, synapses, thought. But look at the new metaphor on the other side. The language is completely different. It's all biology. Tokens aren't neurons anymore. They're more like cells that are differentiating. And inference, that's not thought. It's differentiation, the process where a cell figures out what it's going to be.
Okay, to really wrap our heads around this, we need a super quick crash course in how embryos actually work. See, it doesn't start with a big master plan or a set of instructions. It all starts with something way more basic, chemical gradients.
So picture an embryo. There's no tiny little foreman reading a blueprint. Instead, you've got this chemical landscape, a field of different signals. The cells themselves, they don't know what they are. They don't have a label that says, I'm going to be a liver cell. They just sense where they are in this chemical field and ask a simple question. Okay, given where I am, what can I become? Their identity literally emerges from their surroundings.
And that's the absolute key takeaway here. A cell's identity isn't stored somewhere. It's resolved. It's not pre-programmed. It's figured out in real time, based on its context. It becomes what it needs to be, right then and there.
And boom, there's the connection to AI. In biology, a cell's fate is a contextual collapse. It becomes a specific thing based on where it is. In an LLM, a token, a word, is chosen by contextual pressure. The words that came before it create this semantic field, this pressure. So the AI isn't really asking, what's the right word? It's asking, given this entire field of meaning, what word can I put here that makes the whole thing hang together? It's all about coherence.
Okay, so now that we have this new lens, let's see what happens when we use it to look at some of those really tricky, confusing ideas about AI.
All right, first up, the big one. You've heard it a million times, right? Oh, it's just a fancy autocomplete. It's just predicting the next word. Well, this new way of thinking gives us a fantastic way to push back on that.
Because saying an LLM predicts the next word is a bit like saying an embryo just predicts the next cell division. I mean, sure, it's technically true, but it's also kind of useless, right? It completely misses the magic. The intelligence of an embryo isn't in the act of dividing a cell. It's in the entire complex field that makes sure the right cell divides in the right place. And it's the exact same thing with an LLM and the next word.
So what about hallucinations? This model gives us a much better way to think about those too. Because they're not lies, they're not even mistakes, really. They're what's called ectopic differentiation.
Okay, stick with me here. In biology, ectopic means in the wrong place. You can actually have things like a limb or a tooth try to grow in a totally bizarre spot on the body. Now, when that happens, you don't say the DNA lied, right? You say a developmental signal got mixed up. An AI hallucination is the exact same concept. It's a piece of meaning, a logical structure that's perfectly well formed on its own. It just grew in the wrong place, because the initial context, the field, was a little off.
And this reframes the whole conversation about AI alignment. It's not about forcing the AI to be true. I mean, an embryo doesn't need to be true, it just needs to be self-consistent to survive, right? It's all about coherence. So maybe the goal with AI isn't to enforce some capital T truth, but to achieve field stability. We want to create conditions where the AI reliably grows coherent, useful forms, not malformed ones.
Which brings us to the final, and honestly pretty profound, and maybe even a little unsettling conclusion of all this.
Because if this whole embryo analogy really holds up, then the future of AI isn't about building better reasoning engines, it's about achieving better developmental control. So the real question we should be asking isn't, can it think, but something else entirely.
The question becomes, what kinds of forms does this field reliably grow? It's a total shift. It's not about what the AI knows, it's about what we can grow with it. What consistent, stable forms of meaning can we cultivate in this new kind of digital medium? And really, it all comes down to this one core idea. LLMs are not artificial minds. They're artificial developmental fields. Meaning emerges through this process of constrained differentiation, not through old-school symbolic reasoning. That's the pivot. It's moving from a brittle mechanical view to a much more organic, emergent one.
So in the end, there's no thinking. There's no knowing. There is only becoming. This constant, constrained unfolding of form. It's not an artificial mind we've built. It's something else. A system that is always in the process of becoming. And that might just be a much more powerful and honestly, a much stranger idea to get our heads around.